So let's take a look at another physics attribute called fixed rotation. So to demo that, I'm just going to make, again, a few changes here. So I'll just take my ground, and I'm going to make that a bit smaller. And I'll also take my block character here, and I'll make him a bit smaller as well. And of course, we'll take the time to preview this just to make sure everything still works. And we have our block that falls straight down on the ground. So what I'm going to do is add a little bit more programming into my block so I can control his movement. So right now we have this move straight down, which is essentially our artificial gravity. So I'm just going to fold that down. And I'm going to create a brand new rule. And I'm going to type in the word key, select that. And what I want to do is push the right arrow key. So when the right arrow key is down, I am going to open up the do section and type in the word move and return. So basically what I've set up here is when I push the right arrow key, I want my block to also move to the right. And we can see we have this dial pointing to the right at 300. So let's test that out. So we have one move behavior outside a rule that pushes him down, and if I push the right arrow key, we have another move behavior which pushes him to the right. So watch what happens when I get close to this edge. See how he kind of teeters on the edge here? And then if I keep pushing the right arrow, he eventually goes over the edge, and then I can kind of move around this surface. Now that's actually kind of cool looking, so maybe that's exactly what you want. But because his rotation isn't fixed, he'll kind of rotate around edges because we have that other move behavior pointing him down. So this is actually now his down direction, and if I kind of rotate around here, then that's his down direction, which is why he kind of sticks to this surface. But if we jump into our block and then go again down to the physics tab, you'll notice that we have this attribute here called fixed rotation. And by default, that's not turned on. So watch what happens now if I turn that on and then preview. If I push the right arrow, I can move to the right, and then I can get to the edge, and he doesn't rotate around the edge. That's because his rotation is fixed. No matter what, he will never ever rotate. No matter how many other objects and actors bang into him, he'll never rotate. So if I move to the right just enough, I'll then fall off the platform, which again might be the way you want things set up. So for your main character, you're usually probably going to want to have fixed rotation, or for any other objects that you don't want rotating out in space. But what's interesting, and just for fun, if I go ahead and remove this move from the rule, so I'm just going to take it outside the rule, and I'll delete the rule. So essentially, I have one move behavior that says move down, and another move behavior that says move to the right, and I don't have to push any arrow keys. Then I can essentially pretend that this guy is a bad guy, and if I preview this and turn off fixed rotation, now we have a bad guy that will kind of move around the block surface. So a really interesting setup in case you have a whole bunch of different platforms and then your hero character has to jump from one platform to the next and avoid these really strange bad guys that can actually move around the surface like this. If you're familiar with the old 8-bit Nintendo version of Metroid, there were a lot of platforms that had bad guys that would kind of move around the platform like this. But of course you can have buzz saws or all sorts of interesting obstacles and enemies that would go around a surface. So again, take a moment to experiment with fixed rotation. These physics attributes are really easy to learn, but you really want to take the time to experiment with some interesting values in bounciness and fixed rotation and collide, because when experimenting with physics, you'll actually come up with some really interesting gameplay ideas.